This is Mr. Gran, and this is section 1.6, midpoint and distance in the coordinate plane. So our goals here, develop and apply the formula for a midpoint and use the distance formula and Pythagorean theorem to find the distance between 2 points. So the midpoint formula, kind of the plain English way to do this is to think of it this way. Now I've got 2 points that are x and y, right? I've got a point on my graph somewhere, it's got an x and a y coordinate. I've got another point somewhere that's got an x and a y coordinate. I'm going to take those 2 points and I'm going to average them. I'm going to add the x's and divide by 2 for my x coordinate, and I'm going to add my y's and divide by 2 for my y coordinate. So big issue here, sometimes students want to add everything together, but there's 2 numbers, it's an ordered pair for the midpoint. So our first example, finding the midpoint of this line, the exact center. Not quite as easy as a flat line, right, because it's diagonal, so it makes it a little bit iffier, but I'm going to show you 2 ways to do this. One is the non-math way on a graph, and the other is the math way with the equation. So if we're looking at these 2 points, we've got C, which is at x, y are -2 and -1, and then D, our x and our y are 4 and 2. Now, if I kind of make this into a right triangle here, I've got a horizontal component and a vertical component, right? Oops, that's not what I wanted. I've got this horizontal component down here, the base, and then I've got the vertical component, the height. So I really am trying to find the middle of both of those and then kind of average them out. So if I start here and I count over 1, 2, 3, 4, 5, 6, the middle of 6 is 3. So now I'll count over 1, 2, 3, and I'll make a mark there. Sorry, my son wants to go outside right now. He can't tell that I'm doing something. And now if I do the same thing on the horizontal or the vertical side, it's 1, 2, 3. The middle of 3 is 1.5, so 1 and then 1/2 is right about here. So let me make a mark right there. And now if I go straight up from there and then straight over here, that's going to give me approximately where that midpoint is, will be right here. Now mathematically how this would work is this. We want to average the x's and average the y's. My x's are -2 and 4. So for my x coordinate, if I do -2 plus 4 over 2, then the same thing for my y's. My y coordinates are 1 and 2. So -1 plus 2 over 2. When I simplify those, -2 plus 2, thanks buddy, -2 plus 4 over 2 is 2 over 2, which reduces to 1. It's a little late to go outside, buddy. And then -1 plus 2 over 2 is reduces to 1/2. So our answer is 1/1/2. Now we don't have a graph available to us. Now one thing you could do is throw these points on a graph and try to figure it out graphically like we did to start with that last example, or just throw it right into the equation. That's what I'm going to do here. So we've got 2 values, or we got 2 coordinates, 5, 2, and -1, 4, and they each have an x and a y. Again, I'm just going to average the x's, average the y's. For my x's, it's going to be -1 plus 5 over 2, which that would be 4 over 2, which reduces to 2. Then for the y's, I've got 4 plus 2 over 2, that's 6 over 2, which is 3. And that's going to be my middle value, my midpoint. Now to think about this mathematically, we can do this. Again, I've got 2, 2, and 4, -3. That's an x and a y coordinate, and another x and y coordinate. I can think about this kind of with number lines. My endpoint for the x's is at 2. My midpoint for the x's is at 4, and then my other endpoint is over here somewhere. I'm not sure what it is. Well, to get from 2 to 4, I have to add 2. Then to get from the midpoint to the other endpoint, I have to add another 2, which is 6. Now I can do the same thing for the y's. I'm starting at 2. My midpoint is now at -3. So my number line isn't going in the right direction, but that doesn't really matter in this case. To get from 2 to -3, I have to go down 5. I subtract 5. So now if I start at -3 and I subtract another 5, I'm going to be at -8. And that's what we found when we did this graphically, that our other endpoint was at 6, -8. Alright, now I believe it was 2, 2, so right about there, and the other one was 4, -3, which is right about there. And so the idea here is there's a line between those two, and this is the midpoint. There's another point off here in space somewhere is the other endpoint, and we don't know where that is. So the non-math way of looking at this would be this. Going from our endpoint to our midpoint, I'm going to count down how many down I go, then how many over, and then I'm going to do the same thing from the midpoint to get to the other endpoint. So starting from here, it's 1, 2, 3, 4, 5, so we're going down 5. And then from there, we're going to go 1, 2 over, which is a +2. So I want to do the same thing again. 1, 2, 3, 4, 5. So we're a little bit off the graph. This didn't quite work. And then 1, 2 over. So we're 1 below the edge of our graph right there. That's about where our point would be. And now if I count from the origin to find the coordinates of that point, it's 1, 2, 3, 4, 5, 6. Now I'm directly above it, so the x-coordinate for that point is 6. And then counting down, 1, 2, 3, 4, 5, 6, 7, 8. We went down 8, so it is 6, -8. Alright, the day 2 side, we start with distance formula. Now, we're basically looking for the distance between any 2 points on a coordinate graph. For the first part of the formula, I'm going to give the kind of non-mathy way that's going to tell you what's happening here. So let's start out by making a big long square root symbol and throw a parenthesis in there. We're going to start out with the distance between the x-coordinates, so the horizontal distance between our 2 points, and that's going to be squared, and to that we're going to add the distance between our y-coordinates, and that's also going to get squared. And we'll extend that square root symbol all the way over at the top of everything. Now, the math equation for this looks very similar, but instead of the distance between the two, how we find the distance between the two is we do x sub 2 minus x sub 1. That's the distance, the horizontal distance between the x-coordinates. And then y sub 2 minus y sub 1. And that's the vertical distance between the y-coordinates. Now the x2, y2, x1, y1, that hopefully will make a little more sense with this example. So using the distance formula to find the distance between these 2 points. The first thing I want to do, I want to figure out what my coordinates are. So this point that I'm highlighting in red, let's start at the origin and count over 1, 2, 3, 4 to the left and 2 down. That gives us a coordinate of -4, -2. And now same thing with the other one, this top one, starting at the origin, 1, 2, 3, 4 over, and 1, 2, 3 up. That's going to give us positive 4, positive 3 for the coordinates. And now the negative 4, negative 2, I'm going to call that my x1, y1, and the 4, 3 is going to be my x2, y2. The twos, the ones and the twos have nothing to do with like raising them to exponents or anything like that. It's literally just saying my first x and y coordinate and my second x and y coordinate. Now I can take those and I can plug it into my formula. X2 minus x1 is 4 minus a negative 4. Be careful with negatives here. It's easy to make simple mistakes that screw everything up in the end. And then y2 minus y1 is going to be a 3 minus negative 2, in parentheses squared. Now, I'm going to show the long way here. There are shortcuts, but before you just try to shove all this into your calculator, I would try to do as much of this by hand as possible, because it's a lot easier to make a mistake just plugging it into the calculator than when you're actually thinking about it and doing it by hand. So this is going to, we're going to take care of what we've got in our parentheses first, using PEMDAS, right? 4 minus negative 4, that's the same as 4 plus 4, which is 8 squared, and 3 minus negative 2 is 5 squared. That becomes 64 plus 25. 64 plus 25 is 89. And now when I take the square root of 89, I get, oops, I don't need the square root key anymore, 9.43 is my actual distance between those 2 points. So another example, no graph in this case. I would approach it by starting by labeling my x1, y1 and x2, y2. Again, just saying that that's the first x and y coordinate and the second x and y coordinate. Now I'm just going to plug it back into that formula. x2 is 6 minus x1, which is 1 squared. And our y values, negative 6 minus a negative 9 squared. And all under the square root symbol. Reducing my, or simplifying what's in the parentheses, 6 minus 1 is 5 squared, plus negative 6 minus negative 9 is like negative 6 plus 9, which is 3 squared. 5 squared is 25, 3 squared is 9, so this is going to be the square root of 34, which is 5.83. Now, take a look back at the first problem that we did, because we're going to relate that first example, finding the distance between the 2 points, with using the distance formula to using the Pythagorean theorem. So first off, our Pythagorean theorem is this. For any right triangle, oh, that's a terrible right triangle. Let's try that again. There we go. With sides A and B, legs A and B, and hypotenuse C, the diagonal side, it follows this relationship. A squared plus B squared equals C squared. Now, a graph, it might be a better option to use Pythagorean theorem, and here's why. I can take any diagonal line like this, I can make a horizontal line along the base, and connect it to a vertical line to the other endpoint to make a right triangle. Now, I can count over and say 1, 2, 3, 4, 5, 6, 7, 8. Our base has a length of 8. And our height, 1, 2, 3, 4, 5, is 5. Now, that's going to be my A and my B, and we're looking for the distance, which would be the hypotenuse C. Now I can just plug all those numbers into Pythagorean theorem and figure it out. a squared would be 5 squared plus 8 squared equals c squared. 5 squared is 25 plus 8 squared is 64 equals c squared. 25 plus 64 is 89 equals c squared. And then our last step would be to take the square root. Square root of 89 is 9.34, just like in that first problem. So you can kind of see how in the first problem we used the x coordinates and the y coordinates to come up with the 5 and the 8, but inside that big square root symbol, ultimately we got 25 plus 64 to figure out the square root of 89. So really the only difference is we don't use the square root symbol under the very end here, and it's a little more counting unless this formula is a little bit smaller. So any problem, whether or not you have a graph available, if you want to use graph paper on the quiz or something and just plot 2 points and use Pythagorean Theorem, I think that is a perfectly good way to solve these.